as to what we went through at the end of last week, and then I'll begin with today. So we looked at parabolas, and we talked about number of roots. How many roots can a parabola have, and what do roots mean? What are the roots?
Where it crosses the x-intercept.
Okay, so the x-intercepts, roots, and what was the other thing?
Zeros.
Zeros, because that's what we use, right? Yeah. Okay, so if I take a parabola and we draw that parabola out, let's just start this again. And we notice that it has two roots. We can solve them on our calculator by finding the zeros of the function on the calculator. Now, the roots all occur, when the variable, or so the y value is 0. So I'm going to make this one r is 0 and the other one s and 0. The y-intercept down here is going to be 0 and c. So r and s represent what the two x-intercepts are. The c value represents what the y-intercept is. Now, last week we went through and we talked about this guy right here. What is that called? The vertex. And the importance of the vertex is it told us a few things. What were some of the things that it told us? Maximum or minimum value. Then we got that from the y value, right? So we'll put that as xy. So that was the y value. Okay, what else did it tell us?
Where the line of symmetry is.
Line of symmetry. So that's this guy right here, right? That axis of symmetry. Okay? That was x is equal to whatever the x value of that vertex is. Good so far? Here, I'm going to just change this. I want to change this out because this is what we've been talking about too. We'll call that value h and k. So then x equals h. What else did it tell us? We have max, min, axis of symmetry,
Domain and range.
Domain and range as well. Right? Okay, so those are the things that we looked at last week. So this week, we're going to focus on finding these x-intercepts. Okay, the values of the x-intercepts. Because the values of the x-intercepts will help us find that guy right there as well. Because this is broken up into two symmetrical parts. So if you look at any y value, if I drew a line through this parabola at any y value, the two x values would be the same distance from there as it is to here. Okay? So what does that mean? Well, it means that if I know that the distance from here to here is r plus s, if I divide it by 2, that's going to give me the h value of the vertex. So if I go r plus s and I divide it by 2, that's going to give me the h value of the vertex. That's going to give me the x value of the vertex. Okay? So what I'm doing right now is I'm setting you up to being able to find the equation of one of these parabolas if you're given the graph. It's going to help us find out what the actual equation of this graph is. Okay? Then if I wanted to get the y value of this graph, all right, I would use my y-intercept and I'd stick it into the standard equation. I would solve for it. But there's something else that's kind of unique about the y-intercept. The y-intercept can be found by taking a times r times s. The y-intercept can be found by taking the a value, which is in front of the x squared value, and multiplying it by your r value and by your s value.
The r and s values are your x values.
X-intercepts. When y is 0.
Yeah.
Okay? So if you look at that page 190, they have that all summarized for us. Okay? So this is what they want us to do. They're starting us out saying, so far we've looked at two equations. How can we write the equation of a parabola? Y equals ax squared plus bx plus c. There's one way. That's the general way of doing it. Okay? Standard way of doing it is y is equal to a x minus h squared plus k. In this form here, what can I get from it immediately? The vertex, because the vertex is what? H and k. The third way in which I can do this, all right, is using my roots. Okay? This allows us, then, if only I know my roots, to find the equation of the graph. It helps us find the vertex, and once I find the vertex, I can find everything else I need to know about that graph. All right? So this is what we call the factored form. The zeros of the function x equals r and x equals s. Because when x equals r, the factor x minus r equals 0. And similarly, when x equals s, the factor of x minus s equals 0. X equals r and x equals s are the x-intercepts of the corresponding parabola. The axis of symmetry is given by x equals r plus s over 2. So I wrote it over here as finding h, but it is also the equation of the axis of symmetry. X equals, because what does x equal? H, my axis of symmetry. All right? So these are the three equations that help us find what we need to know about a parabola. So far in this one, the only thing you can do is graph it and then find your pieces. Find your two intercepts, find your y-intercept, find your axis of symmetry from the vertex. This guy, without using the calculator, I can find the vertex. This guy, I can find the x-intercepts that help me find the vertex to give me the axis of symmetry, the domain, the range, and the max-min values. Okay? So each of the three presents a different way in which you can solve questions based on quadratic functions. At the end of last week, we took two quadratic equations and we found out their intersection points. All right? And that was what 7.3 was all about. So let's look at the, and so again, I'm going to use one of these three. Bless you. Okay? But if I'm given a graph, I am not going to use this guy to find the equation. I'm going to use this or this. All right? Now I want you to think back to when we did linear equations in grade 10. We started with y equals mx plus b, right? And you had to find the slope and the y-intercept to find the equation, correct? That was one way to do it. The second way to do it was using the slope formula, slope-intercept formula. X minus, what was it? X minus x1 over, or sorry, y minus y1, y minus y1 over x minus x1 equals slope, and then you had to find it that way. So there was two methods in which we could find the equation of a line from a graph or from information. Here, we're going to use one of these two guys to find out what the equation of the graph is, and then we'll multiply them through so that we get it in that form. Everybody okay so far? So I'm going to show it to you using this example here, and I'll use both methods. So the first thing I do, exactly like I did with linear equations, write out the general equation first. So here's the first general equation. Y equals a, x minus h plus k. Y equals a, x minus r, x minus s. You may want to write this down. All right? So let's look at the graph on page 190. And it wants us to write out the equation. So can somebody tell me what the vertex on that graph is?
Rate 1, 8.
All right. So knowing the vertex, I can do this. come back to it. Okay? So from there, I've got the vertex. So what's the one value I have to find in order to get this equation now? If I already know what h and k is, what do I got to find? I have to find my a value. How do you propose I find my a value now?
Variable.
Okay, but I have too many variables. Okay, so I can't really do it yet because I have too many variables.
You can figure out if it's positive or negative.
Okay, so what is it? Negative because it opens down, right. So I know that. I know when I actually solve it, it should be negative. If it's not, then I made a mistake. So that's really good. Okay? So what do I do? Anybody remember? All right. Take 2. From that graph, what can I find first? Slope. That's the first thing you're going to find on that graph.
Y-intercept.
All right, let's start with that guy. Okay? So, starting with that guy, what's my y-intercept? 4. So I put that into my equation. Y equals mx plus 4. So then how did I find my slope? Rise over run? Okay? So how do I do that?
Y2 subtract Y1 over X2 subtract X1.
Right? So let's make this x2, y2. This one x1, y1. Agreed? Okay? What was the easier way to do that? Got the graph. It's the easier way to find the slope than using the equation. Count it. Count it. How do I go from here over to here?
Down to left.
Down how many?
4,
Down 4,
left 2.
left 2. Negative 4 over negative 2. Would give me the same thing. I could count it. Right? Okay, now let's say I do this then. I'm going to erase all this. All right. Now, okay, so again, I'm just refreshing your memory here because this is going to help us go back. And now what I'm also doing here is I'm setting you up for exactly what's going to happen next year. When we do these questions next year, I'm going to take the parabola and put it up here and show you how to do this because you should know how to do this. Now, I got the y-intercept, but I don't have my slope.
Down 8, left 4.
I could go down 8, I could go left 4, right? I agree to count. I could count it. But let's say I didn't give you the graph. Here's what I gave you. Your y-intercept is 4, and it passes through the coordinate -4, -4. Okay? You could use your slope equation for sure, right? What's another alternative to find out what the m value was here? The line passes through this coordinate and that coordinate, right?
Plug it into the equation.
Plug it into the equation. I could put -4 in for y, -4 into x, and I could solve it. And find it, right? Because I have another coordinate on the line. So I subtract that, that gives me -8. Then what do? Divide by -4. Got my slope is equal to 2. Right? So what did I need in order to find the equation of a graph, of a line? I needed either the y-intercept or the slope. I needed either the two coordinates, or I needed one coordinate and either the slope or the y-intercept, and plug it in. Same thing right here. I've got my vertex. Can you tell me another coordinate on that graph?
-3 and 0.
-3 and 0? 0 equals a -3 plus 1 squared add 8. Right? -3 plus 1 is? -2 squared is? 4. So I've got -8 equals a times 4. Divide. So my equation of this graph in vertex form is -2 x plus 1 squared add 8. Okay? So far we all right? I got one more thing to do with that, but I'm not going to do it yet. We okay so far? Any questions?
So it doesn't matter what coordinate that you take, it's just as long as it's on those lines.
Absolutely. All right. Let's do this method now. Okay? R is one of my roots. S is my other root. So look at the graph right now and tell me what R is.
-3.
So that's x plus 3. And what's my S?
1.
X minus 1. Okay? Give me another coordinate on that graph so that I can solve for A now.
-1 and 8.
-1 and 8? 8 equals A. -1 add 3 times -1 subtract 1. Right? So I just substituted in the vertex. Okay? -1 plus 3 is what?
2.
2. 2 times -2.
-4.
-4 divided into 8. What was the equation in this form? So I just solved it using one of those two methods. In fact, I used it solving both those methods. The same thing again. How did I solve for A in each case? What did I have to do?
Use the roots.
Use the roots or the vertex, and then did what?
Plug in coordinates.
Plugged in a coordinate. Works the same as I do with the line. Nothing changes. Nothing changes. It's the same thing you did last year. We're doing the exact same thing, except we just have the squared values now. And it won't change if we had to do a cubic function. It wouldn't change if we had to do a sine function or a log function or an exponential graph. It doesn't change. We still do the methods the same way. Okay? So far? But then the question says to me, I want it in that general form. So I'm going to multiply this up. Y is equal to -2 times x squared plus 2x plus 1 add, add 8. Okay? Y is equal to -2x squared minus 4x minus 2 add 8. Y is equal to -2x squared minus 4x plus 6. There it is. What's my A value? -2. What's my B value? -4. What's my C value? 6. Okay, let's do it right here too. Y is equal to -2. I gotta FOIL this. X squared minus 3x. Oh, sorry, that's wrong. Need a little bit more room here. Y is equal to -2 x squared minus x plus 3x minus 3. That. Y is equal to -2. I'm going to simplify this. X squared minus plus 2x minus 3 times my -2 through the brackets. Exact same answer in both cases. You'll need to know how to do both methods, but you'll also be able to use the one that you like best most of the time. But you'll need to know how to do both. They're both done the same way. Okay?
So you still, for the second method, you still just pick a coordinate and plug it in.
Yes.
And then you have to put it into general form?
Or if it asks.
Okay.
Everybody's okay so far? All right? 2 methods. Method 1, method 2 got me -2 in both cases. I used the same thing. In method 1, I put the vertex in. In method 2, I put the roots in. In both methods, I put one other coordinate in to solve it. All right? All right, that's all I want to show you right now. They do have one other minor method, but I don't want to do it. Okay, so most of you probably have